This is a very general table of translations, and it is a lot. I would probably screen cap it if I were you, because if you are good at recognizing these things, it's going to make your word problems become much easier. Because it seems like for a lot of people, issues of from word problems don't kind of stem from the fact that they aren't good at math. It generally stems from the fact that they aren't good at taking English words and translating it into math words. And so if you have this table in front of you and you're able to kind of pick out these keywords and word problems, then you'll be able to write the equation and then kind of just use what we've used before, general algebra, to solve from there. So it's kind of a reduced table. This might be kind of more reasonable to kind of take down on your note card. This is also a very good reference point. One thing that is lacking from this table is, let's go back to that last slide, is this left side of equality. You should be looking for those words, is, or whatever to kind of build your equation, but it's nice that this isn't kind of overwhelming. Okay, first question. I want to translate this. I'm not going to really be doing any math. This is just kind of a starting point. I want to translate this into an expression. So the question is saying, what is the product of 7 and 3 more than s? So I'm going to look up to my table and look at these key words and notice that I have more than, which is a plus word, and I have product, which is a multiplication word. And then what I do is I kind of, if I see problems like this, I start to circle the terms that are important. So the thing that I see kind of towards the end is the 3 more than s. And the reason why I'm focusing on that is because I noticed that the overall thing that is happening is I have a product. I have a product of these two separate things, and one of those things is 3 more than s, and the other thing is 7. So 3 more than s is 3 plus s. And then I'm doing the product of 7 and that thing, so that's 7 times 3 plus s. And that's it. I'm not going to simplify any further, I just want to translate for starters. So what is the quotient of 3 less than x and 4? So kind of one of the big operators here, or the big kind of sticking points that I'm falling back on, is that and operator. That means that I'm doing something to both of those separate parts, the things that I'm separating by my and. So one of the things I'm separating is 3 less than x. So I look up into my less than, that is subtraction, and I have to be careful about ordering. So notice how in the ordering it says a minus b. What that is, when I'm trying to translate, if that is b less than a. So that actually means that this first term is going to be x minus 3, which seems very backwards. If you stop and think about it for a little bit, it actually does start to make a little sense, but don't kind of dive into the concept that will work with pretty much every other operation of I'm just going to go left to right. There's a couple of these things, less than, subtracted from, decreased by, or decreased, that will have the operation flipped. So here, 3 less than x is x minus 3, and then I'm doing a quotient overall, a quotient of that thing that I found, the x minus 3, and 4, so there is my expression. This one has a lot of things going on. What is the square of the quotient of w and 3 increased by 8? So again, kind of the goal is I'm going to break it up into pieces so I can start to form things. So the first thing that I noticed is that I have a quotient of w and 3. So I look up at my table, quotient is division, so that gives me w over 3. I'm going to square that thing, so I'll have w over 3 squared. And then the very last step I'm going to do is I'm going to increase that result by 8. Now, writing equations. This is probably the more valuable of the two slides because generally when you're doing a word problem, we are trying to solve for something. We will have an equation we are going to build. And so really the only difference between the last slide and this slide is we have to identify where the equal sign shows up. So the question says the width of a rectangle is 5 inches less than its length. So I kind of lingered on that word is. That's generally a word that means equality. So when I see that, I kind of break things up into two sides. The first side is I take my is to the left of that is width, so that's where my W comes from. And then to the right of that, I see 5 less than its length. So that's where the L minus 5 comes from, and I can put those two together. So this one's a little bit more overwhelming, but we're going to try and identify that word that will break it up into two separate equations. So the engine speed is equal to 168 times the overall gear ratio, gear reduction, multiplied by the speed in miles per hour, divided by the radius of the tire. So oddly enough, the equal sign comes up really quickly in this question. It's the fourth word. So I know my engine speed is going to be equal to all of these things I'm going to talk about in a bit. And for questions like this, when there's so many things going on, you need to start to specify your variables. That doesn't mean that you have to use the same variables as me. Like you might want to use different letters, and that's perfectly fine. But if I'm grading your test and you're kind of just throwing around letters willy-nilly, it's hard for me to kind of understand what you're doing with your work along the way. So the pieces of information I'm seeing on the right side of my equations are the overall gear reduction, the speed, and the radius of the tire. So those are going to be, I believe I did G for gear reduction, V for speed, and R for radius. So I'm going to just kind of have this equation up front and talk about how I get there. So the engine speed, that's my W, that's my equal sign, 168 times my gear ratio multiplied by my speed, so 168 times GV, divided by the radius of the tire R. And so in this way, and it's kind of nice that I have the ability to do this on my computer, but I did specify what my variables are by color coding. I knew that the way that I circled in red was going to be my G, what I circled in blue is going to be my V, and what I'm going to circle in green is my R. But if you don't have colored pencils, which most people don't, then you can kind of just write off to the side, say, okay, this is what G is equal to, or this is what S or what V means, or this is what R means. Now let's get actually into kind of using these tools. I'm looking to build a cabinet whose width is 4 times more than its length. If I have 185 inches of wood, what should be the dimensions of my cabinet? So in this case, I am going to specify my variables pretty clearly. I want to find the length of my cabinet, so I'm going to say that's X when I'm building my equation. I know my width is 4 times more than my length, so my width is going to be 4x. I know that I have 105 inches of wood, and I'm trying to find the dimensions of my cabinet. So I don't really need any more variables at this point. If I set up my equation, and if I'm able to solve for x, I will be able to find my length, and I'll have to do a very tiny amount of work to find my width. One piece of information that might be helpful to know is that what are we talking about with this length of wood? I have 185 inches of wood, and that should kind of tip you off of, oh, this is a perimeter question. That means that if I'm building my cabinet, this is the distance I can make around my cabinet. So perimeter is 2 length times 2 width. Oh, I drew a picture to say exactly what I was saying. Cool. So here's my cabinet that I'm going to make. I know that my length is x and my width is 4x. So to find the perimeter of any shape really, you just add the measurements of all of the sides. So P is equal to 4x plus 4x plus x plus x. I can combine like terms and I will get 10x, and then I replaced my P with 185 that was given in the question. Both sides by 10, I get x is equal to 18.5. And now again, this is why it's very important to kind of label your variables. I found x to be 18.5, but that's not what the question's asking for. It's asking for the dimensions. So then I go back to where I specified my variables, and I say, okay, oh, that's my length. My length is 18.5. To find my width, I need to take that value and multiply it by 4. So 18.5 times 4 gets me 74 inches. This is a perfectly fine way to write the dimensions of the cabinet. Some of you may have seen 18.5 inches with like a giant X, and 74 inches. That is also a perfectly fine way to write the dimensions of a cabinet. While buying parts for your car, you spend $1,873.45. If the tax rate is 9%, how much did you spend on taxes? Set this one up. I want to figure out what my original cost is, and that is not what I have right now. I have the cost after taxes, but I'm going to use that as a variable place. And so what that means is if I have my original cost, again, I'm just using my placeholder of X, but if I have my original cost and I add it by my tax rate, which we actually saw a few lectures ago, then I would get my total after taxes. So that's where this equation is coming from, is it's my original cost plus my tax rate 0.09 times my original cost is going to equal my result. Now to solve for X, I'm going to combine like terms. I'm going to divide both sides by 1.09, and now that I can find what my X is, that is going to get me my original cost, 1,718.76. I don't know why it says inches. It should be dollars. Strange. But that's the original cost. That's not telling me how much I spent on taxes. So I need to go back to the question and see, okay, I have my total amount, I have my original cost. To find out how much I bought in taxes, it is $154.69. Now, if I were to check this problem, in the last one, it's kind of a good idea to check it. You would check it by just adding up the length twice and the width twice, and you would get the perimeter, the 185. In this case, since this is a really tricky one to set up, there's like a lot of cases you could go wrong in that first step. By far, that first step is difficult, getting that x plus 0.09x is equal to that thing. But what I would do for personally to check my answer is I would have actually stopped at my point, my step where I found my x, and I would have multiplied that by the 0.09, added it to itself, and see if that got me back my thing. Because that's what I've seen before. I've seen this tax equation before. I know that if I take a cost, I multiply it by the tax rate, add it together, I'll get the total cost. So that's a really good way to check your answer for questions like these, where it all kind of stems back to, are you building the equation? And if your check is not working, go back and make sure that you've done the math. Go back and look at your translation and make sure that you're doing the process, or that translation makes sense. Go back to what you're doing with your variables and make sure that the variable makes sense in the context of the problem.